Hello, everyone. Thanks for joining our demo day. So let's give a couple seconds for people to join. I see people joining now. We'll give maybe 2 minutes and then we'll get started. My name is Jared. I head product marketing here at HyperTrack. Really excited for this chance to speak with our customers and talk about the platform a bit. We'll get started in about 2 minutes. Before we get started, just a quick heads up on logistics today. We'll go through 3 presentations. There'll be 3 presenters, starting with Ram, head of product, and then we'll go to Saurabh, who heads intelligence, and then we'll go to Eugene, who heads the mobile team. What we'd like to do is have questions after each presenter. So after each presentation, feel free to ask a question in the chat or raise your hand and we'll get to you. So yeah, let's go ahead and get started. Again, my name is Jared McGriff. I head product marketing here at HyperTrack, and we're really excited to share with you these product updates to talk about the platform and share how we're supporting logistics tech builders build these very important use cases. So I'll go ahead and pass to Ram, who heads product, and we'll go from here. Again, if you have any questions, feel free to raise your hand or ask the question in the chat directly after the presenter's presentation. So I'll go ahead and pass it to you. Thanks, Ram.
Great, thanks, Jared. Good morning, everybody. Thank you all for joining. It's kind of early here in the West Coast, but I'm sure people are joining from all over the world. Super excited to share with you the first HyperTrack Demo Day, where we bring our latest innovation to the world. I'm head of product, as Jared mentioned, and I'm going to talk today about the Orders API, which is our API to help logistics tech builders build the entire life cycle of last mile fulfillment from planning, assigning, and tracking. And in particular, it's an API that services dynamic planning when you have live fleet on the ground, as well as orders that are streaming in. The Orders API is a perfect fit for you. Before we get in, just real quick, HyperTrack, as you know, is the last mile API partner for you. So if you need to build anything related to last mile logistics, we should be a right partner for you. So with that, let's get in. So just taking a quick look at what's happening in the industry, I just looked at the news for some recent articles around same day delivery, and what I found was pretty interesting that just last week we had 3 big articles around different industries where players are trying to invest in same day or next day delivery, right? So the first was Target investing 100 million to expand next day delivery. This would be primarily in the day-to-day grocery kind of use cases. There's Leyland SDM, which is more in the heavy furniture kind of space, ladders and construction stuff. They're partnering with Gopher to offer a nationwide same-day delivery service in the UK. And then finally coming to the pet market. So you have brick and mortar retailers trying to unlock, same-day delivery for pet supplies and things like that. And, all of us recently had, we all celebrated Valentine's Day. I'm sure many of us needed to have on-demand orders, which needed to be delivered the same day, which we'd forgotten to order. So on-demand is basically the way the world is moving. And companies essentially need to invest in making sure they can fulfill the same day, next day. Else they're basically risking obsolescence, right? So that's sort of where the industry is going. But what does that actually mean for a logistics planner and for a fulfillment planner, right? In the old world, prior to same day, you'd probably have like an order book that's streaming in over days. And every night you'd kind of, you look at your order book, you'd have some kind of driver schedules for the next day or the following or the future, and then you'd create a route using a simple route optimizer. And basically your orders would be assigned to your drivers, and everyone would be basically, go about fulfilling their day fulfilling their orders the next day. And it's very static, very scheduled, no options to really, accommodate new orders into that route, etc. So it's a very static and set kind of pattern. But the new world that we all encounter as logistics planners is that you have orders streaming in on a daily basis, on an hourly, on a minute-by-minute basis. You have fleet that's moving around in the field, fulfilling orders, changing availability. This might be your own fleet. It might be, a gig worker fleet whose hours you don't control, and they're basically clocking in and clocking out. And as a logistics planner, you're trying to match this moving order book to the moving fleet. And this needs to be fresh so you can, fulfill orders within 2 to 4 hours or right as they're ordered, if it's like a food delivery kind of thing. And so this adds, orders of magnitude more complexity. You have to start planning for it. And that's where, players will typically think, hey, how difficult can it be to build logistics tech use cases, last mile use cases using driver location? When you start building it out, you expect that it's going to be a very simple process. We've all used location as consumers. We share live location. How difficult can it be? You assign an engineer, you can probably build a prototype in-house in like a week or so, because getting started is not that difficult. But as you start moving into production, the reality is really, really different. From a tech perspective, you start to see that you have to optimize your cloud, your mobile tech, and your maps. It's like a three-dimensional tech problem for which you may or may not have the best resources. From a customer experience standpoint, you're basically trying to coordinate the operations manager, the driver on the field, and the consumer experience who's expecting the order to be fulfilled as soon as possible. You'll start running into all sorts of unexpected issues, which as consumers, we don't encounter. So something like, tracking outages when you want to track a driver, but they don't have the right permissions, or the operation or the OS has basically killed permissions. Battery utilization. So one of the big sort of drivers of driver dissatisfaction is apps that actually drain the battery. So you'll start needing to manage, your location stack on the mobile for battery utilization as well. And finally, you'll see driver data explosion, which is basically, if you start streaming location once every few seconds and you have hundreds of drivers in the field, you'll see a whole bunch of data just coming into your cloud, which you'll have to manage. And that's ultimately going to lead to cost explosion, because you have, SDEs who weren't planning to invest now need to start addressing this problem. You have cloud and maps costs that weren't part of your unit economics that are now basically going to drive your costs up. So all this becomes super difficult to handle. And that's where, the HyperTrack Orders API comes in. And that's what we'd love to demo to you today. So the HyperTrack Orders API, it's currently in beta, is a single API to plan, assign, and track order fulfillment. We use dynamic planning, which incorporates driver live location and work. So if you have a fleet that's partially available at your warehouse or store or at your location, and partially fulfilling orders or on their way to the store, you can incorporate their live availability into planning, and that helps you distribute orders more fairly and more efficiently. We support no-code and code-based builders. So depending on what life cycle stage you're in, you might want to, start with a no-code solution and just get started manually, but then move towards a code-based solution where you're integrating APIs and webhooks. That's also possible. And the beauty is it all comes with our simple per order pricing. So we talked about, how costs add up when you're trying to build last mile use cases. You have the cloud and map costs that are really unpredictable. But HyperTrack charges you per order, so it directly fits into your revenue model very, very easily. So with that, I think I'd love to demo this to you. And I'd like to invite one of our senior engineers, Sanchit, who's going to support me in this demo. Hey, Sanchit, do you want to introduce yourself real quick?
Yeah, thanks, Ram. Myself, Sanchit. Yeah, I'm a senior engineer at HyperTrack. Yeah, I'll be supporting Ram with this demo.
Fantastic. So let me actually move over to the demo account that we have set up. Are you seeing my HyperTrack account screen?
Yes.
Okay, great. So like, so we're going to use this account to actually run the demo. Let's walk through the demo setup. So in the demo, we're going to look at a store that's offering 2-hour delivery, and they have a certain set of orders that have piled up, and they have fleet in the street. So we're going to have about 9 orders, and there's going to be a store here. which is trying to fulfill customers in all of these locations for their orders. There are going to be 2 drivers who are right next to the store available right away. And typically in most use cases, you'll see stores that essentially only use drivers who are available at the store for planning. So that's these 2 drivers. But there's also going to be 1 driver who's en route, and the driver is going to be a certain distance away, will take some more time to arrive at the location. And you'll see how dynamic planning also incorporates this driver and is able to, basically assign all the orders successfully. So with that, let's get into the demo account. So as you can see here, this is your HyperTrack demo account. I have 2 drivers who are close to the store here. This is Rosalie and Hazel. And then there's 1 driver who's slightly further away. That's Jonas. And as you can see here, the orders that have been assigned in the store are currently empty. We're going to just run our optimization now. So Sanchit, if you'd like to make the API call in the background, go ahead and we'll see those orders pop up signed over here.
Yeah, taking the call.
So while Sanchit makes the call, HyperTrack is going to match the orders to the drivers and send back these routes via API. And Sanchit's going to receive a webhook when this order planning is completed. Sanchit, let me know whenever you're ready. And
yeah,
wonderful. So as you can see, we've got 9 assigned orders here, and the drivers who've been picked are Jonas, Rosalie, and Hazel. And as you can see, these are all imminent orders. So for 2-hour, basically a 2-hour use case, kind of 11 a.m. It's about 8 right now. It's a little over 2 hours. So these are the orders as in the assigned state. Now let's go to the routes page and see what the routes look like. So as you can see, the 3 routes that have been planned for each driver, 1 for each driver, are over here. Let's click through this one first. So this shows you the route that this driver would need to basically take to fill these orders. So the starting location will be where the driver was, which is close to the store. And then these are the orders 1, order 2, and order 3. Similarly, I have, let's say this one, exact same view for that route as well. Driver starting from the store and then moving to complete the orders. So in this case, he has to go south and then also complete these 2 orders in the north. So this is driver 1. Let's actually dispatch this, which will basically mean that the driver's got a notification now to start fulfilling this order. And while we're dispatching this, what this will do on the API side is HyperTrack will start tracking this driver. So he's only being tracked during the completion of work. We will also generate URLs to share the live tracking with your end consumer. So if the customer wants to know where their order is, you can directly share that link with them, and we'll show you that as well. There's also an operations view that's generated, which we'll show as well, which your operations team can use to debug any orders or update orders as need be. Let's also just assign dispatch a second one to see how that experience evolves. So this is the second route, driver 2. And yes, so now 2 routes have been dispatched, which means 2 of your drivers are currently fulfilling orders. I didn't assign the third one. That's the driver who's currently in the field, because typically operations teams want to have the driver come a little closer to the store before they actually assign that, and essentially, give them that kind of leeway to maybe update the assignment. If another driver shows up close to the store sooner, they can actually change the assignment. And as you can see, each route has a start by time. So this basically means to finish your order by 11 a.m., you need to start latest by these times. The third driver has a little more leeway given he's coming in a bit late. But yeah, these are all very close by orders in San Francisco. So that's why you can start them fairly late, close to 11 o'clock, and you'll still be fine. So Sanjit in the back has actually sent me the embed URL, which is basically what your operations team can use to debug, to monitor orders. So this is the first route we dispatched. The driver is currently here, and he's basically going to travel and finish the orders, 1, 2, and I think there's a third one here. Yeah, so these are the 3 orders that the driver needs to complete. And your ops team can look at that and see that, basically what the ETA for it is. So the entire route is 38 minutes to completion. And he's not yet visited the first order. As you can see, he's kind of further away from all the orders. He's not actually visited the first one yet, but as he starts getting closer to the order location and enters the geofence, this will start clocking to visited. And so that'll tell you that order progress is being made. Similarly, we also have a consumer share URL, which can be provided to your end customers. So this is a single order view of the same order. So the driver's over here. This is the order that's being fulfilled for the customer. You can simply share this URL with your customer by SMS or within your own customer app. And the customer can then directly see where their order is without having to call your operations team. So it can really save you on, call center costs and customer service costs. And as you can see, they can also see the sort of the dot on map moving, basically giving you the Uber-like experience, which is the industry standard right now. So these are the two views to actually, check live progress. Coming back to our orders list, so these were the same 9 orders that we dispatched. And as you can see, HyperTrack has already started identifying risks for each of these orders, which tells your ops team that you might need to check in with the driver or maybe need to call the customer or contact the customer or update customer expectations and improve your sort of customer satisfaction scores. So in this one, for example, Rosalie has actually deviated from the expected route. So and if you double click on it, you'll see some more risks also. She's moving too slow and the ETA is increasing. She also has a low battery, so it's possible that she might lose her tracking capabilities if her battery dies. So this gives your ops team, a view on what risks exist for this order, and essentially, basically now through the orders API, like we saw, we can essentially, plan the order, assign it, and track it, and then as the driver completes the order, it'll update over here as well, and that's how the orders API can basically help you do dynamic planning and manage the entire life cycle of your orders. So that's the end of the live demo. Thanks, Sanchit, for your help. I'll go back to my presentation now and just full screen it. Just to quickly walk through the benefits of dynamic planning, it improves your SLA adherence, especially in the sort of on-demand use cases, typically in the 2 to 4 hour delivery windows. It lets you basically utilize live drivers who are in the field and doing work. It lets you plan orders faster. You don't need to wait for drivers to come back to the store. This lets you get updates out to your customers faster, which again, very much gives them confidence that you're making progress on their on-demand order. It provides better visibility to drivers and improves their earnings. So if your driver is 1 hour away and needs to come back to the store to actually see what work's available, that's going to lead to churn, may make them open other apps to find other work. But this way, if you tell them beforehand, this is the work that's available for you, the chance of them moving on is less, and they'll stick with you and improve their earnings, which is great for driver loyalty, a big problem point in today's world. Your ops efficiency is increased. No longer do you need to manually plan things. You can now only look at exceptions where routes might be outliers if there are too many, or if your SLA is not being met, or things like that. And finally, because you're able to distribute orders better to your fleet, your last mile economics will actually be a lot better. And as all of us know, last mile is about 50% of overall fulfillment costs. So, better economics directly impacts your bottom line. So with that, I'll just open it up for Q&A. Hey, Jared.
Yeah, I don't see any questions in the chat right now.
Mm-hmm.
So let's give it 2 seconds and then we can go to the next presentation.
Sure.
There are no questions. Okay, so I'll read this question from Steve Bono. We have a business case where we have orders to pick up items at multiple customer homes, which creates a route for us and the delivery driver. 2 questions. We will have a situation where we will have an order that comes in that we would want to insert into the driver's route. Is that possible? So the question is, can we insert an order into a set of scheduled orders on a route. And in this particular use case, it would have an order pickup and a delivery stop. The route may see that the deliver may be the next close stop within the route, but the order needs to be picked up first and the route needs to be optimized for pickup and then the delivery stop within the route. Can you answer that question, Ram?
Yeah, absolutely. So great questions. Yes. So the insertion of on-demand orders into existing routes is absolutely a problem for the Orders API. It's currently under development. We've run it in sort of at a prototype stage. So we'd be happy to engage with you as design partner to work through your use case specifically. What we've realized is that every sort of business has its small nuances that need to be addressed when building out these use cases, but that's absolutely something that the Orders API will be able to support going forward. So Steve, yeah, we'd love to connect with you and get deeper into the use case going forward.
And this question is, appreciate the question, Steve, thanks. It is from an anonymous attendee. How do you monitor the battery level? That might be a question for the SDK presentation, but if you want to answer.
Yeah, Eugene's our mobile expert. Eugene, do you want to just hop on and answer that question maybe? Yeah.
Yeah, so you can check the battery level in our APIs. For example, you can get a particular device attached to a worker, and there will be a battery property for that device. And you can also see that this in our dashboard. For example, there will be an indicator, battery indicator in the dashboard. And if the battery is low, you will be able to see that too. And we also have those risks where if the battery is low and it's insufficient to deliver an order, there will be an indicator there as well. And I think this goes on webhooks too.
Awesome. Thanks for that answer, Eugene, and thanks for the question. In deference to time, let's move on to the next presentation. And
there's one more question. Maybe can I just quickly address it?
Yeah, go for it.
Asked, is this solution applicable to drivers employed by single order delivery owner system, or it hires drivers from third parties? I'm considering the availability of drivers all the time in case shortage of drivers in particular area. Yeah, thanks for the question, Shivraj. So, I mean, as an API company, our APIs are agnostic to whether it's your delivery fleet or a third-party delivery fleet. As a logistics tech builder, you can use our APIs to manage both and have a consistent experience across both. When you start getting into third-party sort of driver management, I think there are more operational things that need to come into picture. So we'd love to connect with you offline to see, you know, how that would work in your scenario. There are nuances when it comes to, you know, mixed fleets, but fundamentally our API would work for any driver fleet, yeah, and a combined fleet, yeah.
Okay, let's park this next question and move on to Saurabh's presentation, just so we can make sure we cover all the topics today. Thanks.
All right, sounds good. Thank you for the questions, and I'll hand it over to Saurabh.
Yeah, thanks, Ram, and thanks, Jared. Hi, everyone. I'm Saurabh. I lead the intelligence team at HyperTrack, and today I'll be showcasing our logistics map. But you know, even before we begin, right? What is a logistics map? Well, currently all mapping solutions and capabilities, they align with a very consumer view of mapping. You know, so the kind of places they show, the kind of routes they show, parking locations, etc., are all optimized for regular individuals. But logistics is a very, you know, fast-moving space, and the needs of a map for a logistics person is quite different from a regular one. So let's get started, Ram, if you can move on to the next slide. So for example, when a regular person looks up a parking location, they're looking for a place where they can park safely for an extended period of time. So basically they're looking for parking lots, garages, or, you know, public street parking. And they don't mind a few minutes walk from the parking space to their final destination. A delivery driver, on the other hand, is looking for like a 20-second halt spot, which minimizes the travel distance from their point of parking to fulfillment. And it's, you know, it's all right if it's not like a very proper parking spot because it's only a very quick stop. So, very different requirements from the same view of the world. So at HyperTrack, we are building a map which does this. By tracking millions of orders and billions of location events, we're building a map that uniquely understands the needs and requirements of logistics fulfillment. So let's dive into one such map. Ram, you can go on to the next slide. So, you can play the video, Ram. So by analyzing the behavior of a large fleet of drivers, we created a view where delivery drivers park when they're going about their deliveries. And in this video, as you can see, it identifies roadside stops that may not classify as regular parking spots, but are sufficient for a very quick halt, just to, drop package off. By knowing and routing to these locations, we can increase fleet efficiency, and also by tying these locations to route solving, our routes become clearer, cleaner, and more accurate, and reduces the difference between what we expect and what really happens. Now, this particular map, as we're playing around with it, to create this particular view, we analyzed like 1 billion activity points from across the world. And we organized it in a way that allows us to like zoom in, zoom out instantly and just, observe what's happening where at any scale. And, as we add more activity to the map, it gets denser and more accurate. So out here, you can see it's identified place where fulfillment happened, deliveries, drop-offs, pickups, etc. In a city in India, in Bangalore. And it kind of works all across the world. So that was like parking, which is kind of a way to optimize routes and have more confidence that you're routing to the right place. But that's not all. Let's also jump to service times. Ram, if you can move up to the next place, and you can play the video as well. Ram, you can move to the next slide and play the video there. Yeah, so, all right, yeah, just before that, in the video, this is one of the places that was covered in it. What we see here is we identified, for example, an apartment complex, which instead of having parking outside the complex for drivers, the parking was actually inside the complex next to each wing or block inside the apartment complex. And as you can see, we've identified those points and we can guide directly to those points. And as this map gets more and more filled out, these waypoints, we identify more waypoints that act as a guide for a delivery driver to precisely and quickly get to their target location. Yeah, we can move on from here. Yeah, so let's move on to service times. We analyzed like about 1 million orders to figure out how long it takes to service an order at a particular location. This particular use case is a gig work use case. So as you can see, service times are on the higher side. So every, delivery focused logistics company today uses fixed service times. But in reality, they could be highly variable, ranging from, 30 seconds to 10 minutes, but usually people will use like 3 minutes or 5 minutes. And this variability is, a major source of mismatch between route planning and what really happens on the ground. And that impacts, routing, that impacts, the next order as well. So there's like a cascading set of missing of expectations for your customers. So, by using the insight generated by our service layer, customers can plan better, can plan better. Their routes, will be more closer to what really happens on the ground and just results in higher customer satisfaction. Can you actually just go to the slide after this first? Can you go to slide 7, Ram? Yeah, so just to illustrate this, this was one of the places where you can see that the point marked in black is a 3-minute stop. And that, as it turns out, is a roadside shop. And the 20-minute stop right next to it is an apartment complex. And as you can see, right, there's like significant difference in just knowing whether it's going to take you 5 minutes to pick up an item versus 20 minutes to, on average, drop an item at this apartment complex, which involves signing in, finding the right block, using an elevator, all that stuff. So both these values have significance and value for logistics planning. We can now go back to slide 6, Rob. Thanks. So we showed you an example in the US, and this is another one in Mumbai. And out here, you see the service times, and we'll also show you deviations. So in many countries, and particularly in Mumbai, the location of the destination is problematic because of faulty geocoding or inaccuracies in mobiles used to capture these locations, and many other reasons. So, so in addition to the time layer, we have a link layer called the deviation layer, which is shown in green here. And this actually maps each destination location to where the fulfillment actually took place. And by analyzing these in the context of a customer provided destination ID, we can do a lot of things. We can autocorrect the destination. We can also make inferences about driver behavior and many other things. So as you can see out here, as you browse around the map, and this is on actual real fulfillment data, you can see where each fulfillment happened, what the average deviations were, all that good stuff. Yeah. Cool. Let's go to slide 8. Yeah. So as I was saying, we can identify, some things from these items. So fleet behavior is one of them, where your driver may not mark the location correctly, and they may be on the move when they're marking it as complete, or whatever your workflow is. So allows you to identify errant driver actions which deviate from the expected workflow. So in this case, as you can see, we have high confidence in the location because there is many of the locations fall quite close to the expected location, but there are these few that go well outside. So that allows us to capture those. And from here, you can take corrective actions. This information is also available in the order score view in our product, but this is another way that you can look back in history and identify the same piece of information. Let's go to the next slide. Another thing we can do is we can infer the correct addresses. So in this case, as you can see, the expected location was at some place, but almost all the other locations, almost all the actually marked locations turned out to be near each other, far away from the expected location. So building on this data set, you can then realize that the geofence for this location, and in fact, this address for this location actually lies near all the other points. So we can correct geofences or order destinations. And this is often a major impediment to automated workflows in logistics. So this allows us to get better workflows by making these corrections. And also, this kind of allows us to, for example, in a geofence, it allows us to translate and make it larger or smaller to capture more precisely where work happened. That's more relevant for gig work scenarios, which is the second video we saw, where you can, where based on, your geofence may be at the entrance of like a large place where work happens, but the actual fulfillment region is slightly different. So this allows you to autocorrect and realize that, and then it allows you to understand better what happened in that time while they were inside the geofence. So that's the power of this approach. Let's go on to the next slide, Ram. Yeah. So in conclusion, what are we trying to do? We're trying to enable all our customers to use their own fleet as cartographers to build their own map, where they own the data, and they don't have to keep paying, say, Google, for example, to keep geocoding the same address. Once your driver visits an address, that data belongs to you, and you should be able to use that behavior for the next time when you have a fulfillment at the same location, know the exact latitude, longitude without having to geocode or reverse geocode. So you can use your own data, and you can build a flywheel that improves a little bit with every fulfillment. And over a period of time, what that means is that you build a significant amount of efficiency into your fleet as your fleet does more and more work. So having that flywheel going is very important. And the most sophisticated companies, they do this. Uber does it. Many other people do it. What we are trying to do is we're trying to empower every logistics company to do the same, to have the same capability out of the box. So our vision is we should be able to tell you where to park, after parking, where to walk, and where to knock. And if we can do all that, then we would significantly improve the efficiencies. And we've already started, on this journey of answering these questions. So yeah, that is what we're trying to build here with the logistics map. Let's open it up for questions. We can go to the last slide now.
So I don't see any specific questions to you now, Saurabh. There's one question about potentially looks like meal tracking for students. That might be one we can take offline or answer via chat. So there's no questions we should cover right now. So let's go to Eugene, and we'll catch up on questions after Eugene's presentation. Thanks, everyone.
Fantastic. Thanks, Ram. Moving on to Eugene, our mobile lead, who will talk about the SDK. Thank you.
Thanks, Saurabh. Hey, everyone. I'm Eugene, the mobile lead in HyperTrack. And today I want to tell you what's new in HyperTrack SDK. So on the next slide, yes, let's start with API updates. So first of all, the iOS silent push notification integration. We have greatly improved the way you integrate push notifications for iOS. Now it's fully automatic and doesn't require you to write any code during integration. So it's like a no-code solution. This is especially important if you are using a cross-platform technology where sometimes it's hard to get access to the native OS layer. And this integration is fully backwards compatible, meaning that the manual integration is not gone and you may use it if the automatic integration is not what you want. This also means that because the manual integration path is still there, if you have already integrated the silent push notifications, you don't need to change anything. The new SDK will just work. And by updating the version in the dependency manager, everything will still continue to work. So on the next slide, we have completely new API for outages as well. And this new API is very easy to integrate. You don't need to do any setup with it. Just do hypertrack.errors, and you can handle outages this way. And now we also surface all possible outages in this interface, so you can handle them locally on device without a need to synchronize with the server. And this API also works without the need of active tracking. You can query it at any time during the app's lifecycle. And this means that this new API allows you to create flows where you can query this API before navigating the worker to the feature that requires tracking. And once the API returns no outages, you can safely navigate to the tracking feature, having full confidence that all outages are resolved by the worker. Next slide. We're also adding new subscription APIs. They allow you to subscribe to the data from the SDK. And as with the previous API, there is no setup required to use it. You can just type hypertrack.subscribe anywhere in your code and provide a closure that will be executed when the update happens. The API also returns you a cancelable object that allows to cancel updates. This object also has an added benefit that if you attach it to any view in your app, for example, a view that requires HyperTrack SDK to be active, then if the view is removed, the subscription will be canceled automatically. You don't have to manage it. The API is available for locations, outages, tracking, and availability statuses. This means that if you use it for outages, this allows to build reactive flows where every time the user resolves an outage, the subscription updates and the UI can update immediately. So you can navigate the user through the screens of solving outages, for example. And if you are using this for location subscription, this allows you to place this location on a map and show where the worker is compared to where they were supposed to go. So next, we also improved the user experience of working with key value metadata in the SDK. Now it's native to the language, doesn't require any prior setup. You just open brackets and type keys and values as if it's a native hash map. This works with regular metadata and with geotags. You can also now get metadata in addition to setting it. And the geotag API now returns a location that was attached to the geotag. This is useful if you need to use this location in your flow. So next, we are releasing cross-platform SDKs as well. And we are releasing them for Flutter, React Native, Expo, Ionic Capacitor, and Cordova. All the new APIs are now part of the cross-platform SDKs, including the no-code integration of push notifications on iOS. And because Android push notification integration was already a no-code solution, this means that integrating a cross-platform SDK is now easier than ever, doesn't require touching native code in the process. The APIs are now the same between all SDKs, and they are focused on the lowest friction possible during integration. The iOS SDK and all cross-platform SDKs are already live. The Expo SDK will be released later this week. So next, I want to talk about some quality improvements that we made recently. And next slide. So first of all, tracking quality on Android, we improved the time to get to the first accurate location by a couple of seconds. This allows you to fire webhooks faster and make the experience more responsive without sacrificing any accuracy. And secondly, we greatly improved the fidelity and accuracy of movement capture on Android. So when you want to have high fidelity accuracy of location capture on Android operating system, doing exactly what documentation tells you to do is not the right approach. We found that locations that Android OS gives you by default are low accuracy and are delivered at varying intervals. To mitigate this, we've built a custom state machine that tracks the quality and timing of location updates from Android and manipulates the Android OS APIs to force them to give better location data. And this greater fidelity and accuracy comes at no extra battery cost, and it improves visit detection and allows us to calculate miles driven more accurately. So on the next slide, there is an example, and I know this is a dramatic example of before and after. And this test was a tricky one where there is no raw data on the map, so map matching wasn't able to improve the situation. And instead, our new SDK algorithm captured this walking along the lake at very high precision. And your mileage may vary, and a lot depends on the movement pattern of the worker, but I would definitely encourage updating to the latest Android SDK if you are still using version 5 or below. So next, outage reporting on Android was improved, and all possible outages are now captured and delivered immediately on all APIs. And now it's impossible to miss a location permission not being granted, or tricky cases like permissions being granted only for foreground work, but the app is currently in background. So those cases are fully covered. And when outages are resolved and tracking was on, the SDK resumes tracking immediately and automatically without a need to manage the tracking intent or the precise timing of when the user resolved the outage. The SDK will take care of this and will resume automatically. So next, energy saving. We also made more improvements to the energy consumption of all our SDKs. We do extensive local profiling, simulating movement and observing how different parts of the operating system and hardware behave. And because we use low-level native programming and careful use of resources, our SDK does as little CPU work as possible. and is usually below 1% in profiling. We are also monitoring aggregate data across all customers. This allows us to optimize battery consumption per device model or OS version. And we have found that smart use of networking greatly reduces battery consumption. And our latest SDKs are optimized to send as little data as possible when workers are not actively moving. The aggregate data capture also allows us to fine-tune battery consumption depending on customer and specific movement patterns that are intrinsic to the business. For example, some workers are doing long hauls, some are driving on a scooter, some are working a lot. So we take all of that into account when optimizing battery performance. All of these energy-saving improvements are included in the latest SDK releases. So next and lastly, I want to talk a bit about what we were working on in parallel to this in the last 6 months. We are building a next generation SDK, rewritten from scratch, and we are taking into account all the past learnings from many SDKs updates we shipped in the past. And first of all, we want to make the integration as frictionless as possible for all our customers. This means that most of the time, the integration should be no code. You just add the dependency and the SDK takes care of the rest. We also want to provide the best experience when you need to use an API. Now there is no more managing of the SDK instances or adding configuration in the code. You just do HyperTrack dot anywhere in your code and you can use any API without any setup. The new SDK also allows us to deliver much better location accuracy and improve it over time. And we now use a new robust bidirectional communication protocol that makes our SDK always connected to the cloud, and it can react immediately to REST API invocations from server, or can intelligently wait and only send data when worker's location changes. We're also improving the battery efficiency even more. We are using a common code written in Rust that optimizes the resources we use from the operating system. And we are releasing an alpha version of this new SDK later this week. And we're very excited to hear your feedback on the new and improved APIs. So next, I want to ask if there is any questions on the SDK. Let's give a minute.
So there's one question here. How does the bidirectional SDK to cloud communication help you to be better? What technology are you using for this bidirectional communication? This is from an anonymous attendee.
So when you don't have a bidirectional communication, there is always a problem of synchronization. For example, you invoke a REST API to dispatch an order to a driver. And this should immediately propagate to the SDK, it should immediately start tracking. Sometimes there are use cases when even 1 second is important in those kinds of situations. And before that, we used push notifications and we used long polling on the SDK. And this is not really reliable, especially on iOS. We found that push notification are 95% are delivered in the first couple of minutes on Android, and for example, 30% on iOS. And same way, long polling can not fire at the right time. So what we do now is we use a combination of REST API calls and WebSocket connection. So we open, for example, a socket connection, not send any data, and just wait for any data synchronization to come up. This way, for example, situations are possible where the user cannot move, and we know that the user is not moving because we have the socket connection open, and we don't need to send any data to the cloud because the cloud also knows that the socket connection is open. So this conserves battery life. And when the user moves, we can start sending data or send it at different fidelity and immediately also synchronize the state. Also, this also means that if you are using our SDK, you know when the SDK is synchronized with the cloud. You don't need to manage that like with the previous versions of the SDK, is an API like connection where you know if the SDK is connected or not. So that's another added benefit. Hope this answers the question.
Awesome, thanks. Maybe we can handle Harris's question regarding the driver app. It looks like Ram answered and is answering. Yeah, maybe you could just hop on and answer it verbally. Thanks, Ram.
Yeah, I just typed in my response in chat. Harris, are you on the call? Oh yeah, you're referring to HyperTrack's out-of-the-box app.
Yeah.
So at this point, we didn't have plans to localize, but which languages were you looking for if you're on the call? Yeah. We can, I mean, yeah, so.
We basically built in an ability to localize to any language, but right now it's not localized. And if there is an ask for that, we can do that.
Yeah, Harris. So yeah, if you want to provide more details about the localization request, you can let us know offline. We can just understand your use case. But by design, we're making the app more visual in nature. So the need for language will be much less than a normal app. It'll be more visual and functional in that sense. So there'll be very limited need for localization. We have customers who are using this in different languages. I mean, from different countries who are not very conversant in English, but they're able to use the app. So,
Harris, you can ask your question if you have an additional question.
Hello. Sorry, I had some issues with my speaker, so I didn't hear the first part of the answer. So if you can repeat, that would be great. I didn't hear what was answered.
So yeah, so I was saying that, so I think just summarizing Eugene's answer, Eugene was saying that our app is built in a way where localization is possible. We haven't actually localized it yet. And our design has basically been to be minimal from a linguistic standpoint. It's more visual and app icons. So that helps drivers of different languages use the app. Okay. And that's what we see in different countries, like in Europe, for example. So would love to hear more about, where you see the need for localization, and we can connect offline maybe to take that deeper.
Perfect. Yeah. Awesome. Thank you very much.
Yeah. And
awesome. Yeah, go ahead.
Yeah, there was a question from Karthik. I answered that as well. Yeah. So,
and
hey,
Karthik.
Yeah, absolutely, Karthik. I mean, we're here to help, so feel free to reach out to us on Slack or just set up a meeting and we can connect with you.
Cool. Excellent. Well, thanks everyone for joining. We definitely appreciate your participation and questions, and thank you to all the presenters as well for those demos and your comments. For all of you customers and anyone else, if you have any questions, please reach out to us on Slack. You can also reach us at help@hypertrack.com with any questions you might have. And we look forward to the next opportunity to speak with you all. Talk to you soon, and thank you.